against your program. If this documentation ever gets out of date, then something will break in your testing stage. Any change made to the software gets verified by every example that was created in this process of documenting the requirements as executable specifications. None of this is magic. It's a lot of hard work and requires a lot of discipline across the team, but the results can be amazing. Not only does BDD streamline the requirements process, but it brings the value of QA to the beginning of development. One BDD project I coached involved a complete replacement of a very important legacy mainframe system. The system went live a year early and at 1/3 the cost of what had been estimated using their traditional development method. The ability to execute every requirement against the application let the team regularly deploy new changes in days that normally would have taken 6 months. The business owners identified a small change that would let the application make more money. The change was made in a few hours, but under the old process, it would have taken 6 months to make sure there were no side effects and that it was safe to deploy. Because of the investment in BDD, the change was put into production almost immediately, fully tested and with complete confidence. BDD cut out 6 months where that change would not have been producing any value. For this single change, behavior-driven development resulted in a savings of $5 million that would have been simply lost under their old process.
You're mute.
Okay, I'm saying we're moving on because my animator got just excited with all the dance moves there, and my dance moves aren't nearly that good. Okay, so we're talking about today behavior development, and that video you can find on the Mark Shead YouTube channel if you want to share it with anyone. Is a really quick overview of what behavior-driven development looks like. But we're going to look into that in more detail now. I do want to let you know about some things coming up. Next week, we're going to be talking about splitting Agile stories. This was based on some feedback I got here recently saying that that user stories, we talk about splitting, but how do you actually do that? So we're going to look at some real user stories that I've experienced where we're able to split things down and then talk about some of the techniques from doing that. So this should be really, really helpful. If you've ever struggled with how do I split a story down to something smaller that we can deliver in smaller increments, this will be a talk you'll enjoy seeing. The week after that, David Marsh is going to be talking about making success possible in our complex world. He and I were chatting yesterday, and I think this is going to be really exciting. I'm really looking forward to this talk. And then after that, Agile identifying double agents, so counter-espionage for Agile teams. This was inspired after reading about some things that happened in World War II that got me thinking about if your team was infiltrated, would you be able to spot somebody that looked like they were giving you good information and helping, but really were trying to undermine things? So this will be exciting. And then a week after that, we're going to be doing something I have not tried doing as a lunch and learn yet. This is usually what I do with on-site classes, but we're going to use behavior-driven development to actually program some robots. This is, you probably can't see it very well, there's a big version of it. And I'm gonna walk through, do it live, getting feedback and stuff, and look at what it looks like to do behavior-driven development without dealing with complex code. We'll be using a visual programming language. So if you got people that are interested in behavior-driven development, but maybe they're not developers, and so like watching all the code isn't as interesting, this might be an interesting thing for them to come do. Plus, you get to play with robots. I'm gonna have to change my camera setup to make this work, but I think it'll be fun. Also, I have sent out to many of you a link to a link here to a calendar. If you are interested in getting together and chatting about Agile, I'd love to feel free to sign up for a 30-minute block. I've got about 2 weeks where when I'm free, I'm trying to make time to talk to people. If that sounds interesting, I would love to talk to you about Agile, about the lunch and learns, about Greek mythology, pretty much anything you want to talk about. So there's the link, and I just put it in the chat. I'd love to talk to any of you about that. Okay, oh, same slide again with different background. Okay, what is behavior-driven development? So to explore this, we first kind of have to start with test-driven development, because if we don't kind of define that first, we're going to be very confused about what we're doing, what we're trying to accomplish. So test-driven development, the TDD process, is where we ask ourselves, what is the smallest piece of functionality that would be closer to a working system? So if I think like, what's a method or something that would be one step closer toward a working system, and I imagine what that is, then I ask myself, how would I test if that functionality exists? So I'm imagining what I want this to look like. How would I test, a test that would fail if it doesn't exist and will pass if it is what I expect? Then I write that test. So we start off by writing a simple test. It should fail. If for some reason it passes, chances are we wrote the test wrong. There's also the chance that the application just magically does what we expect it to do and we just didn't know it, but chances are it'll fail. Then we write some code, and eventually we'll write just enough code to get the test to pass. Then we stop and we ask ourselves, is what I did actually sane? I may have gotten to pass, but did I do something really crazy to get it to pass? And if it makes sense, refactor it, get it to work in a better way, make the code to where you're proud of the code, and then go on to another simple test. And we keep going through this process over and over again, very incrementally taking steps while each time proving out that it does exactly what we were expecting it to do in that next step. I haven't done it this year, but I do some demos of this, and for me, it's always a very fascinating experience because I end up coming up with algorithms and ways of approaching things that are much more elegant than I would if I just kind of jumped in and started trying to write the algorithm. So here's some examples of some TDD type tests. So in this case, I've got an adder service, and I want to add the numbers 1 and 0, and I expect to get back the number 1. So I'm going to assert that my expectation of 1 is what I get when I add numbers 1 and 0. And the expectation of 2 is when I add the numbers 1 and 1. So I may have written these tests and run them, and then I'm like, oh, well, I need to deal with negative numbers. So I write some tests to make sure it works with negative numbers. That's what unit level TDD looks like. And I can also deal with this. This gets a little bit technical, but I can also deal with this at this service layer. If you've used Spring, this will make sense. If not, don't worry about it. But I can write these tests at different layers through the application. The previous one was just the function itself. This one's at the service layer, and it actually stands up Spring and makes sure I'm able to do things with the application running. Okay, so that was test-driven development. Let's talk about behavior-driven development now that we've kind of got an idea of what TDD is. Now we can look at what BDD is. So very similarly, we start by asking ourselves, what's the smallest usable feature that would be closer to a working system? And keep in mind, when we say feature, we're talking about the smallest thing that the user would go, ah, this makes my life better. I like this. It could be a matter of making a button do something adding a button to do something very, very simple. For example, one client I'm working with here recently, they're trying to really optimize the way things work in their office. So lots of times what they want is when I type this value here, I want it to copy over here. It's a very, very small usable feature, but it makes their lives better. So what's the smallest usable feature that would be closer to a working system or provide value for the user in some way? Then what we do is we define that behavior as an example. We make that example executable, and then we should see that example fail, right? We try to run it, and unless the application does what we're trying to make it do already, this should fail. Then we use test-driven development to make those examples pass. And I'll show you a diagram of this in a little bit. But the important thing I want you to take away from this slide is it's not like you're choosing between doing test-driven development or behavior-driven development. They work together. One's from the top down, one's from the bottom up. Okay, so why would we want to do this? Oftentimes on software teams or teams that are trying to produce software, you have the developer language over here where people are talking about things that mean stuff to the developers, and then you have the business owner language over here. If those things do not overlap, you're going to have a very hard time communicating, and it's very easy for the developers to build exactly what the business owners told them to build, but not at all what the business owners want. What behavior-driven development does is it says, if we can get these things to overlap, we will be much more efficient at building exactly what's needed and no more. So that's what the Gherkin language does. So it's a language that lets us say, here's a way that we can make things executable, but still are English enough that people can read them. Now the 37 signals, people that did the Ruby on Rails and what's it called, Basecamp, I heard some of their developers saying that this is stupid. Why would you want to do this? But in their situation, their small company, everyone that worked there, at least the time that I had talked to them, they were all developers. There was no need to have this overlap with the business language because there wasn't anyone that did not understand the developer language. If you are in a situation where everyone using the tool knows how to read the code, maybe this isn't as important to you. But most of us probably find ourselves working in situations where we're actually dealing with people that need it in English or French or Spanish or whatever the language is that you happen to be speaking. Taking a look here. Okay, cool. Okay, so here's when I was in college, an English class, and one of the books they gave you to read different essays out of had an essay that I don't think had anything to do with what we were doing, but I found it and it was pretty interesting. So this is by Hayakawa. I think it's a father and son team that wrote a bunch of stuff about language acquisition and stuff like that. And they were making the point just about language that if you have a bunch of villagers that have all these animals show up, a bunch of farmers, and they get together to talk about these animals that came in, and we've got a big version of the animal, small version of the animal. Some of the animals have round heads. We've got these, and some of them have square heads, and some have curly tails, and some have straight tails. Well, one of the farmers raises grain, and he discovers that the small one eat the grain and the big ones don't. So he calls the small ones grain eaters, and that's how he's thinking about it. That's a language he's using because that's what's important to him. Somebody else discovers he's got a lot of snakes on his property, and he discovers that but he doesn't raise grain, so he doesn't notice the differentiation between the ones that eat grain and the ones that don't. But he does notice he has a bunch of snakes, and the one with curly tails eat snakes. So he likes those because those come in and eat the snakes. So he calls those the snake eaters. Somebody else discovers that the ones with the round head, he gets up and he's trying to make a pet out of one. He discovers the ones with the round head will bite him, but the square ones are really, really friendly. So he calls the ones with the round heads, biters or something like that. And then somebody else whose crops did not do so well discovers that the ones with the square heads and curly tails, like these here, no matter what size they are, those actually are good to eat, and they evidently taste like chicken. But the point is, all these people get together and talk about these animals that come in, and their language does not overlap. It's not a matter of they just have different names for things. It's not like this one calls these, A, and other people call it B, and other people call it C. The way that they've divided things has to do with what they actually need and the way they interact with their world and what's important to them. And now the reason I bring this up is because when we're doing stuff, when we're going through and creating BDD scenarios, this becomes very important because these are the type of ambiguity that we're sorting out, of trying to make sure that everybody has a good view of what the system needs to do from all the different aspects that are involved in it. So I like this diagram because it kind of reminds me that language is a very, very tricky thing. And what behavior-driven development does is tries to get us to the point that we're leveraging language to make it easier to develop instead of hitting it as a brick wall. Okay, so let's look at an example. Here's an example of a BDD scenario. Given I am not an admin user, when I log into the system, then I cannot see the admin menu. Okay, well, then most systems probably have this as a scenario somewhere. But now notice this is fairly structured, right? I've got a given when then. Let me show another one here. Given I am an admin user, when I log into the system, then I can see the admin menu. Now, this probably describes most systems that you've used. It's very, very simple. But notice it's structured too, right? I've got the state of the world that I find myself in, given I'm an admin user. And then I've got what I did. I logged into the system, and then I've got the results I expect. Then I can or can't see the admin menu, depending on what type of user I am. And this structure gives us the ability to make this executable, but this makes sense, right? We can read this even if we don't see any code or don't even understand how code works. Most people can look at this and understand, here's an example of what I expect the system to do. So with BDD, we end up with a loop that looks something like this. We'll start with a scenario. We'll watch it fail. We'll make it executable. Then we're going to write some code. And eventually the scenario is going to pass, and then we'll go to the next scenario. Now, we might write several scenarios, but we'll turn them on one at a time, right? We'll work our way through them. So we may have written several scenarios. But the idea is we're taking one of these scenarios at a time and working our way through it. So BDD helps us create our requirements. It's a process for making sure we get good requirements. BDD is fundamentally a change to the way that you create requirements that drives a change to the way that you do development. BDD helps keep requirements continually fresh, because if we make these examples execute against the code, if our system ever deviates from what the BDD example says it should do, something will break and we'll have to update our example if we expect it to do something different. So this is usually the point that when I'm teaching these class slides, people are saying, is this just another way to do user stories? A user story represents work, right? It's basically the smallest way that we can represent the work so we can prioritize it and keep track of what's in scope and what's out of scope. A BDD scenario is created just in time, right? We're not usually using BDD scenarios to try to prioritize the work. There's no sense writing a BDD scenario for something if you're not even sure you're ready to work on it. So we want the BDD scenario created just in time. And one of the reasons for that is the value is less about the scenario. The scenario definitely has value, but the thing that's really valuable is the conversations that come about to try to create the scenario. So if we do that way ahead of time, we lose the benefit of having those conversations just in time before we start on the development work. So a common anti-pattern I see is when people start trying to create BDD scenarios way far out ahead of development work. I was working with a team in New York, and the Scrum Master was like, I'm going to really help the team. I'm going to do this BDD scenarios for the next 6 months. The problem was that communication and trying to figure out how to make things unambiguous that happens when you sit down and work through these together, like figuring out which animals bite and how to name these things. That didn't happen because she was trying to get out ahead of stuff. I mean, well-intentioned, but it's very important to make sure that we think that what we're getting out of this is the communication process. And yes, we get the scenario out of it, but the thing that's really, really valuable is having those conversations. BDD scenario, detailed acceptance. Is it a detailed acceptance criteria? It can be thought of that, but think of it as an example of what something does. Which is a great way, that is a great way to say this is the acceptance criteria, the system does this. But if we think of it too much as acceptance criteria, we end up steering away from examples and just kind of documenting instead of saying what somebody will do through the system. Let's see. Yeah, so it becomes, I think it's a good way to, it will embody examples of the requirements. And the reason I want to be careful to kind of separate those is you may still have requirements over here that you need to meet. And then from that, you say, okay, what's examples of how the application will behave to meet this requirement? For example, I may have a requirement that people can only see the menu options that they have access to. Something like that. That may be the requirement. Well, the example of that is I log in as an admin user and I can see the admin menu, right? So there's a subtle difference there. And yes, it's showing the requirement, but it's a specific concrete example of how I would experience that requirement. It might be one way of putting it. Okay, so let's talk about 3 Amigos, and not necessarily these three Amigos, but we'll use them as a picture. So we got these 3 Amigos, but we're going to have the developer, the business owner, and the tester. And these represent 3 hats that we want to bring to bear on the problem of creating examples of what our actual requirements are, or creating examples of what the business needs. And so when we're having a session where we're creating BDD scenarios, we want to make sure that we've got all of these hats, right? We've got the business, we've got the developer, and we've got QA. One of the anti-patterns, common anti-pattern, is leaving out one of the hats. If the developer and the QA, if somebody that represents developer and represents the QA decide they're going to get together and write the BDD scenarios without the business there, you're likely to not get the full value out of BDD that you're going to get because you're not having the communication with the business. Same thing that happens if QA and business get together and decide to leave out the developer. But when you've got all 3 of those aspects represented, it's a lot easier to have the conversations around the business ask for this. Developers say, based on the known laws of computation, that is impossible. But why are you trying to do that? And the business says, well, I'm trying to do this. And they say, okay, we think we can get you 90% of that by doing this other thing, and it's really, really easy to do. And business goes, oh, yeah, that's great. That's the part I need. And then QA says, okay, but what happens in this particular situation? The developer goes, oh, I didn't think of that. Maybe we should do it like this. And they talk through it and figure out, like, okay, now let's write an example of that. And now we're ready to start on the development work. Don't overvalue the artifact. So the BDD scenario that we end up with is important. It's going to be very, very useful. But the real useful thing is the process. Okay, so we talked about BDD, talked a little bit about TDD. Let's look at how those things actually work together. We're doing on time here. Okay, good. So this is the TDD process, right? Simple test, watch it fail, write code. And remember, this is a simple test about some piece of functionality we expect to have. Some function or method in the application. So it's very much at the bottom level, the way that the developers think about the application. Sometimes these tests might not make a lot of sense to the business owner or users, and that's okay. BDD, on the other hand, is written from the standpoint of a scenario or an example of how the application behaves. This should make perfect sense to the business owner if they're used to working within that context. So this was the outer loop the loop for BDD. If we put those things together, we end up with an outer loop of behavior-driven development. But when we get ready to make it executable. When we're writing the code, we go into this inner TDD loop and we start writing things like, what functions do I need to actually make this work? Eventually it passes, then we move on to the next scenario. So we've got this outer loop of BDD, an inner loop of TDD, an outer loop of the executable specification, and an inner loop of the unit and integration tests. So here's some examples of examples of how to word stuff, because we want to word these things in a way that we're going to be happy reading them over the next 4 years, 10 years, future generations, or whatever. So here's an example. So multiple givens. Given one thing, given another thing, given yet another thing. When I open my eyes, then I see something, then I don't see something else. This is a perfectly valid cucumber statement, right? As a matter of fact, all those keywords are completely interchangeable. They're just there to trigger the match. But I could replace all of those with then, all of those with given if I want. Now, I want to use those words though, because the givens state how I set things up. The when is what happens, and the then is what I'm checking for. But as far as the way the parser is working, it doesn't care which keyword you use. Which means I can make this read a lot better. So I can say, given one thing, and another thing, and yet another thing. When I open my eyes, then I see something, but I don't see something else. So those are all valid keywords to use in Gherkin. And all these keywords do is trigger it to look for, how did the developers say to do this next thing here? Okay, so one important thing to think about when we're thinking about BDD scenarios is, since they represent an example of how the application is behaving for one story or what you're delivering, they're going to change over time. So you may deliver a story and the BDD scenarios are written in a particular way for that particular story, but the next story may come in and change it or add to it. And that's just fine. You should think of these as things that you're drawing with a pencil, not something you're doing with a chisel, right? You're sketching out how the application works and giving examples of how it's going to work in this next step. And it's just fine to come back and make changes to that. As a matter of fact, you should be expecting to make changes to it. So sometimes your next iteration may be taking an existing BDD scenario and modifying it and maybe adding another, or maybe just modifying is all it is. Like when we were in this situation, we expected this to happen. Well, now we need there to be a subtle difference in the way it works when it happens on Saturday or whatever. So we're going to change the BDD scenario, or maybe you are writing another scenario. But the big point is you need to think of these as things that you're going to be sketching and making changes to. Okay, so here's the part this is where I try to make what we're talking about very, very memorable, okay? So this is the behavior. We're going to look at the behavior of a Sphex Wasp and write it out as a BDD scenario, and then we'll see if there's any bugs in the Sphex Wasp programming. Okay, so this is Sphex Wasp. What a Wasp does is it will, I'll go through the scenario. We'll just look at it, the examples of how the Wasp behaves. So given the Wasp burrows into the ground and lays its larva in the ground in these holes in the ground. I think they have these in Kansas. They're pretty prevalent. They're pretty widespread, I believe. So given the wasp is stocking its nest, putting food in its nest so the larva will have it to eat when they hatch. When a cricket is located, then the cricket is paralyzed. It stings it, but doesn't kill it. And the cricket is moved toward the nest. Okay, so here's an example of a piece of what this wasp is programmed to do. So it moves it toward the nest. Given the wasp is headed toward the nest and the wasp is carrying a cricket, when the wasp reaches the nest entrance, then the wasp will drop the cricket, so it leaves it outside the nest, and the wasp will inspect the nest. Okay? Now notice this is very structured, right? But this is very Englishy. We can understand this. You don't have to understand code to understand what's happening here. Given the wasp has inspected the nest, when the wasp exits the nest and finds its cricket at the entrance, then the wasp will retrieve the cricket and store the cricket for its larva. So the cricket lays there immobilized until the larvae wake up and eat it alive. So yes, horribly disgusting. But let's watch this in action with a, so this defines the behavior of the wasp. Now let's watch how that plays out, okay? So it stung the cricket, it's dragging it back to its hole. And now its program says it needs to go inspect the nest. But a human comes and moves the cricket. So it comes out and it resets, right? It now has to drag the cricket to its nest. So finally finds it, drags it to the nest, and the program says, now leave it and go inspect the nest. So the video, I'll throw the link up here in just a second if you want to watch more of it. But at this point, the person making the video said he has done this about 40 times. I think once the antennas fall off of the cricket, the wasp no longer recognizes it and it'll wander off and do something else. But we've just found a bug in the wasp programming, right? But what I think is interesting here is we were able to represent this behavior with just a few examples as a BDD scenario. If you're interested in the video, there's where it came from. It's up on YouTube. You can go check it out if you like watching wasps drag things around. So I showed this to my kids, and they did a little mini retrospective, and they said, okay, so the problem is someone keeps moving the cricket. The solution is sting the human. So fortunately, it didn't happen to that guy. So let's look at some other examples of things that you may have experienced. So imagine that, given it's the first week of school and the students are learning from home, when a student logs into the virtual classroom, then an error message should be displayed. Did anyone encounter this maybe a few years ago when everybody got sent home to work? I think there was some scenario that was being executed for many people that were making that happen. Let's see. Lori, reach out to me and let me know. Let's talk sometime and see if we can put something together or schedule actually, somebody's private messaging me. Let me throw something in here for you. I mentioned this before. For people in the Agile LnL community, if you'd like to get 30 minutes with me, just kind of talk through anything anything I may be able to help make suggestions on Agile stuff, or that's related to the LnL or anything, feel free to put some time or just reply to an email with me, but that will get you on my calendar. Okay, so here's a scenario that often applies to me. Given I'm going to be on video and my office is a mess, when it's 10 minutes before start time and panic cleaning is initiated, the mess will be pushed just out of view, right? Anyone else have that happen? Here's one that I would love to see, a scenario I'd love to see on more systems. Given I have entered my social security number at the phone prompt, when I finally get to talk to a real person, then they should see my social security number has been verified and not ask me for my social security number again. Or the other side of this, given I've entered an invalid social security number, and when I finally get to talk to a real person, then they should be required to enter my social security number and then proceed with the support call. And my point here is just there's lots of different things that we can represent as very simple examples that we can make executable to execute against the application. Here's one that I did with a team that worked out pretty well and was very, very useful. This system processed a lot of files. So the first story we did is, given I have a valid X-type file, it's been submitted, when the process runs, then a file accepted message should be returned. Okay, very, very simple, but it says if I have a valid file, here's what I expect to have happen. But we had lots and lots of different ways we needed to test for different things. So what we did is we took that valid X file, whatever format it was, and said, given an otherwise valid X file, but the header contains an invalid character. This line right here actually took a valid file, put an invalid character in the header, saved it again, and then fed it to the running the process, and then made sure that we got the error that we expected. Now, the beauty of this was if the format of this file changed, it was pretty easy to deal with because we just had to change the valid file that we were then going to modify and then run the process on. So you can do some really, really incredible things with behavior-driven development. Last team I had been working with they had a new member join, and he came up with all kinds of ways to do really innovative things. Now, you don't want that to become your program and most of your effort in that, but there's ways to, since you're doing this in code, you can do some very, very intelligent things to test stuff in ways that would be very difficult to test with manual testing. In this particular thing, given an otherwise valid X file, but the first amount field is set to Bilbo Baggins, when the process runs, then an amount must be numeric error is returned. So lots of things that we can check here. So everything we've been talking about is like, this may look really powerful and everything, but you may also notice, hey, this looks like something that's related to regression tests. Now we've got regression tests, and that is true. Regression tests are a side effect of behavior-driven development, a very valuable side effect of behavior-driven development. But if you think of behavior-driven development as mainly being a way to create regression tests, you'll probably do a lot of things that will make you avoid the biggest benefits of it. We're not just trying to create regression tests. We're trying to find a better way of doing development that lets us communicate better with our customers, with QA, and have all three of those hats really talk through what needs to happen in order to be able to develop more efficiently, get things right the first time, and work in smaller increments. So if you are in a team that's trying to use BDD, this is something to watch for. Make sure that you're not so focused on them being regression tests that you miss the benefit of the communication that happens. For example, I've seen some teams where they write all the code and then they kind of throw it over the wall to someone else who goes in and actually writes BDD scenarios to run against it. If you're doing that, you really need to ask yourself, is the cost of using BDD higher than the value you're getting? Because if one of the big benefits you get from it is to facilitate the communication, that toss it over the wall kind of removes the whole communication aspect of making sure we talk through everything. You might find that it's just as efficient to write those tests. If you are going to throw it over the wall, just write them in JUnit or whatever your testing tool. That might be just as efficient because you're removing the part of it that probably gives you the biggest advantage, which is to facilitate the communication. So those are things to watch for. So here's a question I've been asked. I was talking with someone last week about how do you train a team on behavior-driven development? And one important thing I think to think of if you're looking at adopting behavior-driven development is to look at something like this. Let's see, I see it's really hard when team has that ingrained in them. So I think, Sean, you're talking about like the tossing stuff over the wall. I'm not familiar with IWF, so what does that stand for at all? I don't know if I can answer because I probably won't. If I don't recognize the acronym, I probably won't recognize the word. But yes, Sean, that's a good point. It's very hard when you're used to throwing stuff over the wall. A couple things that can help with that is if you can get teams more aligned, like everybody more aligned, a cross-functional team that's aligned on delivering small increments. Usually the throw of stuff over the wall has developed that way because we're working in bigger batches. If we say we don't want to throw stuff over the wall, but we keep trying to work in bigger batches, it's probably going to be very, very difficult to change. If you start getting to where you're working in much smaller batches, you can usually make a better case, or it's easier for people to see the value of actually trying to develop more, bringing the testing to the beginning and stuff. Iterative waterfall project. Okay. The iterative waterfall projects, I probably don't have a great answer to it, but it probably depends on what you're actually iterating on, right? If you're trying to iterate in the idea of we're going to do all this planning up front, do all of our requirements up front, there may be a way to use it, but if you're actually iterating on where your requirements are developing and you're delivering pieces of stuff all the way through having conversations, it probably would work really well. That's an interesting question. I'm going to think more about that. Okay, so here's this. One of the big things when teams are looking at learning behavior-driven development that I want to make sure they start with is our goal here is not to do BDD, right? It's not just we're doing behavior-driven development because we want to. We want rapid and safe delivery of value. We want to be able to get stuff safely and quickly into the customer's hands so they can make money, so they can pay us our paycheck, so we can continue to deliver valuable software to the customer. The only way we can do that is if we actually invest in build automation and continuous integration, which this is where you're actually running your BDD scenarios. The only way to do that, or the only way to actually have something to automate and continuously integrate is if we're using behavior-driven development and test-driven development, and probably DevOps in here as well. The only way we can successfully do BDD and TDD is if we get good at having small changes, right? If I'm trying to do massive changes, BDD and TDD are a lot less useful to me. And the only way I can do a good job of story creation and sizing and small changes is if I've got a fundamental foundation of basic Agile values and principles. So the reason I show this is it's really easy to say, hey, we want to do this right here, without actually laying the foundation for being able to do this successfully. And teams that forget this part often fail at this stage. Also, even if they do get all this right, if we don't make sure we're focusing on this stuff up here, we won't be prepared to actually take advantage of the changes we're trying to make to the way that we're doing development. So BDD and TDD the value they provide is very much dependent on being able to have the right foundation and being able to have the process that lets you actually take advantage of what you're doing. How to convince the org that small change, small batch doesn't require comprehensive functional regression tests of the entire app? Or is the expectation that this process will build 100% of the functionality to test coverage? That seems unlikely or expensive. If you build an application like this from the ground up, so one project I'm thinking of, previously it took them, it was either 6 developers, 12 weeks, or 12 developers, 6 weeks, same number of, testers, same number of testing hours into it. That's how long it took them to test their application before they could deploy it. Even with that much testing, they often deployed to catastrophic results that messed up their data and stuff. And this was a very important system. When we replaced the system using behavior-driven development, they could get better confidence in between 20 minutes and an hour that the entire application worked than they ever got by having people manually test it. So the idea of it being expensive, if we're thinking in terms of the processor time that goes into it, is they were using big servers to do that, but the cost was so low compared to being able to compared to not knowing if the application worked correctly or not. Yeah, what Jeff is saying, the regression suite is a byproduct of BDD with Cucumber. But Richard, to your question, running processor cycles are pretty cheap, right? And if you run stuff in parallel and you approach trying to do stuff in parallel, you can get the value of the confidence that your application hasn't broken anything. I think we often don't take into consideration how valuable that actually is to be able to say, yes, this application does exactly what it's supposed to do. Because if our application does anything that's valuable, the ability to make a change and say, yes, it all works good, I can deploy it right now, in a week or in a few days or maybe even in a few hours. If I can get feedback on a change in 20 minutes, there's nothing that will probably keep me from actually deploying that all the way through to production. If your application does something valuable, that's probably worth a huge amount. But that's a very, very good question. Okay, so talking about, we're on the topic of training teams. Here, somebody else had asked me to kind of go through and list out, here's what I usually, kind of an approach to training. So I went back and looked at the teams that I've worked with. Often these I was working with them for, maybe a year or so at the time. And I pulled out everything that we did in training for it. So generally, this is what I've found has worked well for, to get teams up to speed on behavior-driven development. Now, the place that you really, really learn is hands-on, working together with somebody that's done it before and developing the software and just, delivering stuff for the customer and trying to do our best to delight the customer. But usually I try to start with teams and saying, let's make sure that we understand the Agile principles. And like that chart I just showed you, how this is going to support behavior-driven development. Then I usually talk about, I've got a talk I've done. You've probably seen the talk just kind of in its non-BDD form, but courageous software delivery. I've done that quite a few times for the Agile Lunch and Learn. But the idea of we want to be able to lower our risk, that kind of talking about courage isn't just doing things foolish. How do we lower our risk and work in small enough increments that we can have courage to do things with low risk and actually deliver for the customer? And how does behavior-driven development help us with that? Then I usually do a longer version of this talk right here that we're doing right now, of just explaining the high-level concepts of behavior-driven development. And then I usually do the robots, except for if I'm in person, everybody pairs up, gets a robot, and works on some things. Jeff Braxton and I did this for a conference one time, and it was a lot of fun. He took everybody out in the room and said, okay, you guys are the business owners. I'm going to give you the requirements, and you go back and you have to tell everybody on your little team with it. Anyway, it was great. This is kind of the foundation I usually try to go through to make sure that everybody around the team that's dealing with, that's going to be experiencing behavior-driven development or hearing about it and stuff, understands what we're trying to do. This isn't super technical, but it helps make sure that we're that everybody's set up for success. I've been in places where we didn't do this type of stuff, and you have people all over the organization going, oh, they're crazy, we don't know what they're doing. This helps remove the, what's that crazy team doing from it, and gives people the foundation they need to understand how the technical details of what they're doing. The next kind of track we do is for people who code, right? And we go through and we do the Cucumber BDD live coding, a test-driven development live coding. I've done these on the Agile LnL, and we'll be doing them again at some point. But then we usually follow up and actually let them do a workshop where they get to code it themselves, pair up with someone and do some BDD coding themselves, and then also doing a test-driven development workshop. So this helps get people just enough tools in their repertoire that they've had some experience with it, that they ought to be able to take a project and start bringing behavior-driven development to bear on the problem. Somebody asked what robots I'm using. These are Ozobots. So that's what I usually use for this. Okay, and then the other piece that I found is very key for trying to get a successful team successfully transition to using behavior-driven development is to make sure that leadership knows how to take advantage of these new capabilities and to lead and manage a team that's doing stuff that's very different than what they've probably experienced before. So I've got leading BDD on Agile teams are really thinking of how do we, a lot of this is focused on how to take advantage of small iterations, which is what the BDD efforts are going to facilitate. Then we do a delivery flow simulation. I've done that here. It's been a while where we do the token flipping to really get people thinking about, I'm not focused on just what my department does, but how do I make sure I get value through the whole system? And then we've got, I've done the cost of delay talk, but one focused on how that works with behavior-driven development, how behavior-driven development and all the other things we're trying to do with Agile helps lower the cost of delay. So those are kind of the tracks. The first one is foundation. We try to get everybody through and then kind of separate things for people that code and then kind of the business and leadership. So I just wanted, since I've been putting this together for someone else, I want to throw this out here because I think it's a helpful way to just think about if you're wanting to switch a team to using behavior-driven development, how do you set them up for success? Covering these types of things I've found have been a useful way to set teams up for success. And if any of that stuff is interesting and you want to talk about it more, let's see, I went the wrong way. Like I said earlier, I think we got some new people on, so I will post that here. I've got over the next 2 weeks, I've got some time and I've got slots available if you want to talk about behavior-driven development, what you're trying to do. I'd love to talk to you about it. Feel free to set up some time on that. Love to chat. Or like I said earlier, we talked about Greek mythology or dog training or anything else of interest. Okay, so let's look at an example of behavior-driven development or an example of scenarios and then watch it play out as I terrify my young children with a robot. So this is a follow me robot, right? I should have brought it over here. It's a turtle bot I've got over on the other side of the room, also known as baby duck mode or terrify your kids robot. There's our angry robot that's going to terrify our kids. So here's our scenario. Given the legs of a human are identified, when the legs are to the right of center, then rotate. When the legs are to the right of center, then rotate to the right. Okay, so this is a scenario that will get me facing toward the human if the legs are to the right of center. Okay, given the legs of a human are identified, when the legs are to the left of center, then rotate to the left. Okay, these two scenarios give examples of how I'm going to lock onto the human that I'm trying to terrify or terrify, either way. Okay, so another scenario. Given the legs of a human are identified, when the legs are more than 2 feet away, then move 2 inches forward. Given the legs of a human are identified, when the legs are less than 2 feet away, then move 2 inches backwards. Okay, so this is going to get this kind of creepy effect of I'm following you, but I won't get too close. Okay, so this is the behavior of the robot that we've just described. Now I'm going to show you unleashing this robot on my son. He's quite a bit older now, but I still like this video. Okay, so here's the robot. He's going to have it. It's going to start following around the room. Okay, slow down.
Now walk toward it and see if it will back up. Okay, come over to me. Okay, now run by it really fast. See if you can get out of its range. Good job.
Okay, so it's an example of behavior-driven development, also example of how I am preparing my kids to avoid robots when the robot apocalypse happens, right? You know, you got to get out of their sensor really quickly. And the sensor on top of it is kind of like a Microsoft Kinect. It's a different brand, but that's what it's doing. It's creating a 3D scatter plot of the environment. Anyway, so, but what I wanted to show you is those examples we just had right here, you know, these are pretty simple, right? That's pretty simple. But man, you can have really creepy behavior just with some really, I mean, it looks like it's alive trying to follow you. I had some other friends come over the other day and the dad was telling his daughter, I don't know, Mark might unleash his robot on you. And so people in my town are terrifying their kids by the idea that the robot's going to follow them around. Okay, so here's these things. Now, these are very much written from a standpoint of how we would describe how we as mere normal people would describe what the robot's doing. But we can do these at different levels, right? We can be at the 50,000 foot level or we can be at the microscopic level. So I could go even higher level than what I have and say, given the legs of a human are identified, when follow me is activated, then follow the human, okay? So that would be one thing, even higher level. Now, this might not be quite as useful for actually walking through the different pieces of stuff. When I do when we do this example coming up in a few weeks with the, you probably can't see this. So this is that little robot I was showing earlier. We're going to navigate a maze. And if I just had, you know, given the robot's on a maze, then it can solve the maze. Well, doesn't tell me really the details of how it's doing it. So we're going to deal with how it handles the color of each intersection. So that might be too high level for this, but there's times where we may actually want to have a scenario that works like this. I was working with one team and they would put a scenario like this at the very top and not even make it executable, just so they knew at a really high level what I'm trying to do here. Because they'd come and see this and go, oh, okay, I understand what we're trying to do. Now I understand all the detail things that come down below it. So they'd have this at the top and then, and then they'd have all these details that they'd actually make executable. And for them, that was a good way to use the tool. Okay, so high level 50,000 foot view, maybe this is more microscopic. If we needed to, if there was value in it, we could go even more detail of describing the plot, the 3D scatter plot that's coming back from this sensor. That might not have as much meaning to the user unless the users were, you know, robotic programmers or something like that. But if you got into that, you might be better off doing it in code. So here, another example, your brain, right? Given it's lunchtime, the speaker keeps talking, then discard 85% of what he says. So that may be where we are right now. I'm not sure. Okay, so how does this work? How does everything come together here? So we have the feature file. So the feature file over here is going to contain all the English words of the given when then. Then it's the plain English examples. Then we have a steps file. This is the code that actually backs what we're trying to do. So it's the code that the feature file, when it says, I need to, given I'm on the login page, this is what gets me to the login page. And then I've got the actual program that I'm trying to connect to. Now, if anyone's trying to do BDD, particularly with a web application, and you're doing it like this, you want to make sure probably that you insert in the middle here a page object, which basically acts as an API to the web app. So just think of this in terms of this lets you do something. If you change your login to where instead of it being the username, you change it to email, you don't want to have to change that in 5,000 different scenarios, right? You want to change it just in one place. Page object is what lets you do that. So if you're doing anything like this, and particularly if it's becoming painful, look up the page object pattern. It will make your life much, much easier. So let's look at what these look like. So we've got feature file. Here's an example of a feature file, right? Add two positive numbers. Given I'm on the demo page, when I add the numbers 2 and 3, the result is 5. Scenario, add a negative and positive number. It's another scenario, add 2 negative numbers. So this just lays out examples of how this application would work. And this application just lets you add 2 numbers. It's a calculator to add numbers, right? But behind the scenes, this is what gets interesting, is here's the steps file, and here's how it maps, right? So given I'm on the demo page, calls this right here. It goes out and it matches with that regular expression right there and gets to the demo page object and calls go. Now, one thing that Cucumber, and I think most tools that you'd use for behavior-driven development do this really, really nice, is if I run this and it does not know how to, I am on the demo page, it will give you this snippet right here without that line on 28. And it says, hey, put this in your code, and then on line 28, put what you want me to do when you say to do this, and now I'll match on that. It's a very simple thing, but man, this makes this a lot easier because it will say, I don't know how to do that. Here's a snippet of code. Use the snippet of code and then tell me how to, and then fill it in with what you want me to do. When I add the numbers 2 and 5, now notice this 2 and 3. 2 and 3 right here, if you notice, are in blue in the, this was IntelliJ, but down here, it looks a little bit different, right? Given I add the numbers, and then there's this regular expression right here that's going to pull a digit out, and then the and then another digit. So what it's doing is it's passing those as arguments into this method. So this is really nice because I don't have to write, like what I was on right here. Let's see. I don't have to write a new thing to match for 2 and 3 and -2 and 3 and -2 and -3. I just have to write one of these and it will match for all of those. So that's one really, and there's other things you can do this like really, really interesting, but that's in the basics. So I'm calling the demo page and passing in those arguments. Same thing for the results down here. So this is going to match on this right down there. So that's the basic structure of your feature file and then your steps file. And then, oh, okay, the page object that I was talking about. This gets a little bit technical. If you're interested in it, look it up. But if you notice this page object, all the information about the IDs on the page is confined to the page object. So this is relevant for BDD or doing anything in Selenium. If I ever need to change one of these IDs, I want to change it in one place, not every single place that had steps that touched this. Okay, cool. I've got a few minutes, so let's look at some other examples. Arabic to Roman number conversion. So given I'm on the demo page, when I convert the Arabic number 1, then the Roman numeral displayed is I. 14, then the Roman numeral is XIV. And behind the scenes, this is the code that's matching that. And this is very similar to what we just looked at. The thing I wanted to show you, though, is I can also do this as something like a mail merge. So here I've got a table of examples, right? And it's going to execute for each line in that table. It's going to execute and put the Arabic number in here and the Roman numeral in here. So an Arabic number is what we're used to, the 1, 2, 3, 4, 5 base 10 system. What it's going, but it will put that in here. So for every one of these lines, this is a whole lot easier to read and to go through this and just kind of understand what's going on than maybe where to go? Whoops. Then maybe this would be, right? Having 100 examples like this wouldn't be very useful, but it wouldn't be completely crazy if I wanted to list out 100 or a bunch of examples in this particular one where I'm just looking down a table. So let's take that table idea and let me show some examples of, yes, Graham, this is how you learned what mail merge was. I used mail merge with a team I was working with a while back and everybody's like, what in the world is that? And I realized I am old. Okay, so here's another example of that type of thing. So given a document status, document exists, when the user type, document action, the document, then the action is, and the result. So that doesn't read very well, but if I look down here at the table, this makes a whole lot more sense than probably having all 5 of these listed out as separate scenarios. So I can say the document status is approval pending and the user type is admin. When they try to view it, then it's allowed. But if I get down here and it's approval pending and they're an editor, when they try to approve it, then it's blocked. So this is really, really powerful because it's a very easy way to make sure everybody understands exactly what the application does. I've seen some people use this type of approach to where they listed out every single page, like 20 pages in the application, and every user type, and whether that user had access to it. Every single time they made any change to the application and checked it in, it would run through and make sure they hadn't messed up their security somehow. And that's, it takes time to run, but the confidence they had for being able to deploy when the entire application was built with that level of confidence was huge, worked really well for them. And we can mix and match them, right? Maybe I want a few examples like this, and then I'm going to go ahead and put them down here with my table. Let's see. Oh, one other thing is this is just a text file that you check in with your code. So some teams have found they actually take the user story that prompted this and put it at the beginning, or maybe even the JIRA number to refer back to why were we doing this. Now, what I find is this stays up to date. So the JIRA number over the years will probably stop being useful, but it's there if you ever do need to go back to look at something, and can be really useful while you're doing active development on it. Okay, so we have a user story, we've got a Cucumber scenario, and then we've got a Cucumber feature file. These are all things that we're going to, that we kind of talked about here. So a user story, just go through is, as a user, I want to convert Roman numerals and numbers to Roman numerals so I don't have to do it in my head. That's a typical approach for a user story. Doesn't tell me much about how it's happening or anything, but if I have this in JIRA, I can decide, the customer can decide, do they want this next, or do they want that functionality to add two numbers together next, right? It's just enough for me to be able to prioritize and have some idea of what's the constraint of the story. There's no sense in me doing a lot of work on this if this isn't the next and most important thing for me to work on. The Cucumber scenarios look like this. So this is a feature file, and then these are individual scenarios within the feature file. And then this is a scenario outline, which we'll pull from the examples tab. User story is a high-level representation of the overall goal. The Cucumber scenarios are a specific example of an aspect of the feature, and the Cucumber feature is a collection of example scenarios that complete a feature or are related to one particular way of the application. There's no limit really what you put into a document. It's just a matter of how do you want to group things so you can find them. Something is ringing and I don't know what it is. Okay, so bringing that back to, not sure what that is. Give me just a second here to see if I can stop it. Well, that was exciting. Okay, so bringing it all back to, remember this stack right here of rapid, safe delivery of value, build automation, which is built on having build automation, which is built on having things that we can automate, which is built on being able to have small story sizes, which is built on the basic Agile values and principles. And I think if we keep this in mind, we can take advantage of the things we do at this level. But if we forget the top and bottom here, it's easy to do this in ways that doesn't actually help us moving forward. Let's see, I'll check the example things in a minute. Coming up, splitting Agile stories next week. This is something that I know is it's hard to do, but it can make a huge difference in your ability to actually deliver stuff incrementally. Dave Marsh is going to be talking about making success possible in our complex world the week after that. Really looking forward to that. Agile identifying double agents, counter espionage for Agile teams after that. And then we're going to do the live coding demo where we're going to go through and do BDD. Like I said, this is one of the training things I do with kind of at the foundation level for teams. We're going to do that on the Agile Lunch and Learn so people can see it. I'll just demo it to you. I need a document camera set up and stuff, but this is going to be fun. Okay, so that covers... Yes, that covers what I wanted to cover here. Once again, I'll throw this link in here. If anybody's interested in meeting over the next few weeks for 30 minutes and just talk about Agile or Greek mythology or dog training or ways I can help your team or suggestions or feedback on these Agile Lunch and Learns, I would love to talk to you. I'll stick around for a few minutes. I think there were some comments here I didn't see, but thank you all for coming. And it's great to see everybody, or see that you're on, I guess.